So this is going to be 0.7788 times 4. We have 3.115 moles of Cl2. So guys, this is how much, or the amount needed. Now check it out. I can stop right here. I want you to look. I want Carson Dye to tell me. Carson Dye, I need 3.115 moles of chlorine. How much do I have available? 1.408. Do I have enough? No. Let's say I want to buy something that is $3.12. I only have $1.41. I don't have enough. So you can go on, and I'll go on just for the sake of it. Let's see, we have 1.408 moles of chlorine. We're going to convert it. 4 moles of chlorine on the bottom. 1 mole of S8 on top. 1.408 divided by 4 is 0.352. Jade, this is the amount of S8 that we need. Okay? So Jade, we need 0.352 moles of S8. How much do we have? 0.778. Do we have enough?
No.
Jade?
Yes, sorry, yes.
Why?
Because you have 0.7.
So imagine this is down here. Guys, imagine this is like 35 cents. You need 35 cents. You have about 78 cents. You have enough. So S8 is your excess reactant. Chlorine, or Cl2, is your limiting. Yes, Arshan.
So if you have like the perfect amount, like 0.778 S8 and 3.115 Cl2, would there be no limiting reactant?
You would say that both are the limiting reactant, and they will run out at the same time.
Okay.
All right, so for those of you at home watching this lesson, let me go over what we just did one more time. What we do is we will convert the moles of both of our reactants into moles of our unknown substance, which is S2Cl2. And whichever those values is going to be less is going to be the limiting reactant. So we can see that 0.7788 moles of sulfur produce 3.115 moles of disulfur dichloride. 1.408 moles of chlorine is going to produce 1.408 moles of disulfur dichloride. This number, 1.408, is less than 3.115, which means that chlorine is going to be your limiting reactant. The other method that you can do is you can convert one of the reactants to the other. So if we use 0.7788 moles of sulfur, we will produce 3.115 moles of chlorine. This is the amount of chlorine that we need. If we look up here, this is the amount of chlorine that we have. 1.408 is how much we have. We need 3.115. It's not enough. So chlorine is your limiting reactant, and sulfur is your excess reactant. Are there any questions? Francis?
What about the thing that we did yesterday?
Forget yesterday.
Don't use that.
Don't use that. We're gonna never happen.
As long as you know how to find it, it's fine. Limiting reactant.
Yep. Forget yesterday even happened. Okay? Deal?
Okay.
Good. Wipe your brain of it. Men in Black, flashy thinking. You're done. Yeah.
How did you get S2Cl2 like in the chemical reaction with S8Cl2?
S2Cl2 is the product. Hey, you guys, I know what it's like learning chem for the first time. So whatever questions you have, say them. Are we good? Okay. This is a 3-part problem. That is the first third. Determining the limiting reactant and the excess reactant. Now, we are going to try to figure out how much product is made. But I want you to look back at the word problem. It says, in bright green, what mass of disulfur dichloride is produced? So what will our answer be measured in?
Grams.
Grams. Good. So we are going to go on to part 2, which will be to convert moles of the what is LR? We're going to convert moles of limiting reactant to mass of the unknown substance, which in this particular problem is S2Cl2. We need to do it. We need to turn it to mass. We haven't done it to mass yet. We did it to moles. So Arshawn is right. We did half of that problem already, but we're going to go back up here and let's see. Just so you guys will be able to handle this all on your own. Jade. Jade, what is the amount of moles of our limiting reactant? I know there's a lot of numbers here. Give yourself a second. Tell me what it is.
1.48.
You got it. So the moles of our limiting reactant is 1.408 moles of Cl2. We need to convert that into mass of our unknown substance. So according to the word problem, this first step is going to be mole ratio. Guys, this problem you're doing is what we did the day before yesterday. Actually, no, we did it on Tuesday. Tuesday. Mole to mass, which is a 2-step problem. So we're going to put 4 moles of CO2. Mr. Thorson, where did you get the 4 moles? I'm going to tell you, Colby. We got it from right here. And Colby, how many? If there's 4 moles of CO2, how many moles of S2Cl2 are there? 4. All right, so this is a 4-to-4 ratio, which is basically a 1-to-1 ratio. Now, if we stopped right now, what would your answer be measured in? Is that what you have to have? No, you need mass. So 1 mole of S2Cl2. And if you look on the periodic table, S2 is 32.1 times 2, which is 64.2. You add 71 to that because chlorine, Cl, is 35.5. There are 2 of them. 35.5 times 2 is 71. So I know that I just said all that, but some of you are very much visual learners, so I'll just hash it out here. In S2Cl2, sulfur is 32.1 grams per mole. There are 2 of them, so it's going to be 64.2. Chlorine is 35.5 grams per mole. There are 2 of them. That equals 71.0. We then add those together. 135.2 grams per mole. That is the molar mass. So 1 mole on the bottom, 135.4. Did I put 4? No, 2. That's right. 135.2 grams of S2Cl2 on top. And your setup is complete. All you have to do is solve. 1.408. If you want to do times 4 divided by 4, that's fine, but it's basically 1 over 1. So I'm going to skip that step. Now I'm going to do times 135.2. And I've got 190.4 grams of S2Cl2. Did you guys get that? Okay. So what this value represents is the maximum amount of product that can be produced. And that's the second third of this procedure. How are we feeling? Better than yesterday? Okay. Now, the last step, the third and final step here that you might be asked to do is you're going to be asked to determine, here we go, calculate how much excess reactant remains after the reaction. So by definition, the excess is going to be how much is left over. If I have 8 hot dog buns, 10 hot dog wieners, I'm going to have 2 hot dog wieners left. So what you're going to do is you are going to, first off, begin with moles of your LR and convert to mass of your excess, which should be a pretty easy step. This is going to be moles to mass.
Is the excess in grams or mole?
We're gonna right now it's in moles, but we're going to, I'll tell you, this is a multi-step process. All right. What I would tell you is let it play out. We're going to use the moles that we did during the conversion. Jade, you okay?
What?
You look like you were frozen in time, like you didn't understand. That's called a hand, Jade. You have 2 of them. You looked a little freaked out by it. You doing all right?
Yeah, but I know.
Oh no. All right. So according to my numbers back up here, my amount of my limiting reactant is 1.408. 1.408 moles of Cl2. And what we're going to do first in this conversion is we're going to have the mole ratio of our limiting, Max, wake up, of our limiting reactant to our excess reactant. We have 4 moles of our limiting reactant. We have 1 mole of our excess reactant. And now we're going to convert the moles of our unknown, or excuse me, our excess to our mass. So 1 mole of S8 is equal to, let's see, I already forgot, 32.1 times 8 is 256.8. 1.408 divided by 4 times 250, oops, 1.408 divided by 4 times 256.8. 90.39 grams of S8. Now, guys, listen up. This number is the amount of excess used up, or the proper term would be consumed. Okay? Kevin, how much S8 did we start with when this problem began? Okay, so Kevin says we started with 200 grams. Here's what you do. Subtract amount of excess consumed from initial amount. So Kevin says we started with 200 grams of S8. We consumed 90.39 grams of S8. We have 109.6 grams of S8 remaining. You have now achieved all 3 facets of this type of problem. The first part, identify what the limiting reactant is. The second part, identify how much product can be made. In the third part, identify how much excess reactant is left over. So I would love to give you guys an example problem, but we are low on time, and these do take some time. So here is what I'm going to ask you to try to do. You can get started on it now, and I want you to find all 3 parts and bring it into class on Monday. On Monday, you're going to do an in-class worksheet. So here's what I want you to do. You have the equation. Let's see if I can figure this out. P4 plus 5O2 yields P4 O10. Here's what I want you to do. 1, determine the limiting reactant and the excess reactant. Step 2, after determining the limiting reactant, calculate the maximum amount of product produced. And the third and final step, calculate how much excess remains. You can get started on this now. I bet you can at least accomplish step 1 before class is over. You have 6 minutes.
What are the grams?
The grams are going to be as follows. You have 25.0 grams of P4, and you have 50.0 grams of oxygen. These are your initial amounts. You can also call this amount available. So this is what you have in your pocket. Is it enough? That's what you're going to find out. All right. I feel like that went better than yesterday. I'm going to stop the recording now.